Hey guys, Frank Cox here. I'm super excited. It's Friday night and I'm actually home this time. Anyway, happy hour is beginning in the Midwest anyway. Right now it's 5 o'clock and I'm super excited for tonight's show. A good friend of mine, Roy Elkins, is going to join us today. And, there's this mythical creature that exists out there that, typically I've never met one in real life. So that's why I'm saying mythical creature. But there's actually guys out there that repair broken welders, and that's who he is. He's a welder repair technician with a boatload of experience, and I'm super excited to have this conversation because I'm sure he's going to help me understand some things that maybe I don't already know about. So anyway, we're going to play the old intro here, and we'll be right back in just a second. Roy, I am so glad that you was able to join us tonight. I don't know if you heard my intro there, but I called you a mythical creature.
I've been called a lot of things, Frank.
What's that?
I've been called a lot of things.
There you go. Yeah, so we always have trouble with our machines, and we of course blame the manufacturer and all of this kind of stuff. And I bet typically it has nothing to do with the manufacturer. There's probably a lot more to do with us, and I'm excited to hear what your input on some of that is. But real quick, I'm going to introduce you to the folks. This fella right here is Roy Elkins, and he is with Baker's Gas. And true story, he's a drum cooker guy, and that's how I know him. And he's got some other cooking utensils around. And one day I was having some trouble with one of my machines, and he jumped in the old chat there and got a hold of me in my DMs and said, "Hey, by the way, just so you know, I'm a welder repair technician." And then I was just like blown away that they exist. So anyway, tell us a little bit about yourself there, Roy, and kind of your story about how you got into all of this.
Basically, I'm just a welder repair tech. I used to work on cars for a living way back in the day, and started working on welders about 30 years ago. Worked on gas drives, diesels, and propane-driven machines for 10 years of my first in my career, and then moved on to the electric machines. So I've moved up from there. So been repairing welders for about 30 years now.
That's awesome.
What I do for a living, I repair broken stuff. I can repair pretty much anything, but they pay me to repair welders.
Yeah, that's cool, man. So what made you make the switch from auto body car related stuff to this?
Well, to tell you the truth, I had a friend that worked at a welding repair shop, and he would come home and he would ask me questions about engines he couldn't get running or stuff like that. So I would help him out with that stuff. And he goes, "Man, you need to come up here and get a job." I'm like, "Nah, I'm good where I'm at." So time went on, and finally I did. I went up there and got a job, and pretty much that's how I got in the welding industry. Just from my knowledge of working on engines, and it just went from there.
Gotcha. So tell me a little bit about Baker's Gas. I mean, you search something on the internet for welding, and Baker's Gas comes up pretty darn high in the list. Tell me about them.
Baker's Gas is a unique company. We're a small, big company. We have 10 locations. We're located in Southeast Michigan, Northern Ohio. We have a total of 10 stores. All repairs come to my location. I do all repairs for all 10 stores. Number 10 store is an online store only. It's basically a warehouse where if you go to bakersgas.com, that's where your stuff's going to come from. And basically, it's just a warehouse that is full of welding stuff, machines, safety gear, you name it, we got it.
That's awesome. Yeah, I'm going to put that down here in the chat for you guys. Baker's Gas. There it is. Yeah, so you guys are pretty much, you deal everything from what I understand. I mean, there ain't nothing you don't have.
No, sir. We are we're a very different kind of welding company, actually. Welding supplies is a big one, but we're also a gas supplier. So we have transports, and we deliver oxygen, nitrogen. We deliver argon. We deliver, CO2. So we do that. We also are Baker's Propane. We have a large propane company that we ship a lot of propane to people's houses. We also do commercial propane. We do temporary heat in the wintertime, which is a big business for us because we sell propane.
Oh, yeah.
We also provide a fire extinguisher program. Actually, my boss's one of his first projects was the fire extinguishers because he was a fireman. And two of our stores, the one that I work at and another one located in Jackson, Michigan, we actually have an Ace Hardware store located in our facility.
You know, I noticed that you sent me a hat. When you sent me those parts the other day, you sent me some hats, and there was a hat in there that said Ace Hardware, and I was like, really? This is an Ace Hardware chain too. That's really cool. Yeah.
And at our Ace Hardware store that I work at, we also have a large rental fleet. You can rent anything from a bulldozer to a weed whip, and I do mean anything.
That's awesome.
So we also do that. So we stay very busy.
That's cool. That's cool. So you also cook some barbecue here and there. How long ago? When did you start cooking?
I wish I could cook more barbecue than I do work on welders, but you know how that goes. But yeah, I love barbecue. Yes, sir.
Yeah. So tell me about your arsenal there. I know you got a drum cooker.
Yeah, a drum cooker. So you got the Draft Master. That's a fine cooker. If anybody needs one, get it from Frank. He knows what he's doing. That sucker at 300 all day long. Got a Welder kettle, of course. I got a Holland. A little Holland grill gas grill, and I have a dome cooker. So I have a little bit of everything, a flat top, a little bit of everything.
That's cool. Yeah. So do you ever do any competitions or anything?
Yes, sir. I've done some competitions. I like to do competitions, but it's tough finding a good team. It really is to find people to cook. I could do it myself, but then I thought about it like, nah, that's too much work.
It is a lot of work.
It really is. It really is. Yes.
Yeah, you just need at least somebody to run and help kind of keep control of the environment.
Yeah. But it's nowadays I do more. Guys will bring me meat. I'll smoke it for them, stuff like that.
That's cool. That's cool. So into some stuff, guys. If you have questions, make sure and pop them down here in the chat. You have a rare expert in the chat here that, and I'm going to get into it and hear some stories. But I mean, as far as like welders that aren't functioning correctly or issues you've been having, let's kind of talk through some of that stuff. I know that Roy's got a lot of information that he can whoop down on us, and I've got my own questions for sure too. So as far as like repair, like welders, like what's the most common failure that you see? Like there's got to be one thing that you're like, well, dang it again, seriously.
Truthfully, lack of maintenance, like everything else. The lack of maintenance. You got to blow these machines out. That's probably the biggest thing is, especially on MIG welders or electric stick welders, that fan sucking in air, it's sucking in dirt.
Yeah.
And grind dust and all that stuff. So it's pretty much maintenance. You got to keep everything tight. I mean, keep your leads tight, keep all that stuff tight. Anytime something gets hot, it's loose. I mean, stuff shouldn't get hot. Ground clamp are probably the biggest downfall of most people because they think, well, it looks good, it feels good, but if you grab that ground clamp and it's hot, it's not right.
Yeah, and it's not like a welding shop is a clean environment after all, Yeah, it's sitting right down there, getting the grinder dust blowed in it.
I have customers that the first thing I do when we get a machine in, take the sheet metal off, you put it out in the power wash area, and you power wash it out before you even touch it because it's got so much crap in it. It's just, I don't want that. It's just too much crap.
Just power wash the sheet metal or the inside of the welder?
The inside of the welder.
Oh, wow.
But yeah, power wash it out. Ain't gonna hurt it. Power wash it out, let it sit a day, and then go ahead and work on it. That way you ain't working on crap. Especially when you work on stuff from steel mills, places like that, concrete plants. Man, there'll be 1 inch, 2 inches of that crap in the bottom of them. Gets in the contactors, it gets everywhere. Power
Yeah.
wash them, set them aside, let them dry out. They'll be fine.
Yeah.
Even if,
So
go
go
ahead.
ahead. Sorry.
I was gonna say even inverters. Everybody's always scared to power wash inverters because there are all these electronic parts in there. Power wash it, blow it out, let it set for a day, fire it up. It'll be all right.
Dang, that's intense. So my background in commercial refrigeration supermarket stuff, I wouldn't necessarily do that on something like what I'm working on, but I could see because I guess they do go an extra mile to protect some of those controls and stuff, from the environment.
Oh yes, I mean nowadays the new PC boards are potted so much that you're not going to hurt them with a power washer at all. And I'm not saying get in there and blast it. You just want to get in there and clean that stuff out. So,
Hmm.
mainly because you ain't got to work in it.
Yeah, yeah,
You know,
totally.
and a lot of the times, that's the only thing wrong with the machine. It just can't breathe. It's got so much crap in it. Because nowadays fans are fan on demand. They only run when they get hot.
Hmm.
So if you got a fan that won't run when it gets hot, it's going to shut down, give you air code. You got to wash
Yeah.
them. You got to keep them clean.
Yeah, that's good info. So as far as like machines go on the MIG welder end of things, because I know most of us are MIG welding kind of guys. Like, what machine do you think is probably the most well built machine out there that you like? It's the easiest one. Is there one? Let's ask that.
I'm a Miller man. I like Miller for a lot of different reasons. I like the way they draw their wiring schematics. I can read them easier. But I've always been a Miller fan. Blue is my favorite color, but maybe that's got something to do with it. I don't know. But I
Yeah.
prefer a Miller machine. Um, I have 2 Millers and a Lincoln in the garage right now, so I'm not opposed to a Lincoln. Um,
Mhm.
so my top two would be Miller Lincoln.
Yeah, that's good. So do you think that one really outperforms the other? I mean, because you're the guy that's fixing it, so you ought to really be like up on that.
No, sir. No, sir. There's not one machine made better than the other. No. If you're
Yeah.
dealing with top line machines, no. There's not any machine. A Miller, a Lincoln, and an ESOP. That's in my top three. They're all made solid. I mean, they're all good machines. It's all personal preference. People come and ask me that all the time, and I always tell them it's like Ford, Chevy. It depends on what you prefer.
Yeah. It boils down to color and looks and interface and those little things that really don't make that big a difference probably to how it runs. Yeah.
You're absolutely right. Yep. You cover it up.
Yeah.
I tell you a story back in the day when Miller first brought out inverters. Lincoln always had the pipe welding industry wrapped up in pipe welding, the SA200, stuff like that. They weld pipe all day long with those things. They put an XMT 304 in a gray machine. The guys were welding with it, and they would say, "Man, this thing welds so great. What is it?" And they showed it was Miller. They about cried. So,
So they would put the Miller guts inside the sheet metal for the
yeah,
Lincoln.
you make it look like he was welding with the Lincoln, like SA200, and they would love the machine because they thought it was that Lincoln, but really it was the XMT 304 inside there welding with.
Oh my goodness, I never heard such a thing. That's hilarious. So as far as like the smaller end of the machines, um, as far as so if a guy's just welding 1/4 inch all day, and he's a smoker builder, so he's not running that thing at a really high percentage. He's just running it a little bit here and there, and those kind of things. What do you think about the smaller machines compared to like making that jump up into a bigger machine? Like, are they going to wear that thing out or anything? Is there any reason that you would recommend don't get a small machine?
Yes, sir, because a lot of people buy a machine that's too small for what they want to do. So they're
Hmm.
constantly running on the high side. So they're going for the maximum output of the machine. They say, well, it'll weld 1/4 inch. So, but they got it
Hmm.
all turned all the way up, and they're just running the piss out of it all day long. Where if you stepped up to a little bigger machine, you're not running it wide open all day. If
Hmm.
you want a race car, you don't buy a Volkswagen.
Yeah.
So Buy something that you don't have to run wide open. It's like you or I. If we work wide open all day long, we get real tired. But if we take our
Yeah.
time all day long, we seem to last a little longer. But and the same goes with plasma cutters. People will buy that. They'll buy that plasma cutter that'll cut 1/8 inch, but they're pushing it every day. They're pushing it hard every day. It won't last as long.
Yeah, yeah. That's something you bring up because I bet you work on a lot of plasma cutters too. Can you kind of go in because I I have my own idea of what's happening there, but kind of go into that a little bit. How does them things like actually work?
Well, they take air and they run it through your torch, and once the electrode and the nozzle separates, that creates the plasma that you're cutting with. So clean air in a plasma cutter is its lifeline. If you don't have clean air, your plasma is going to be crap. You're going to go through a lot of consumables. Consumables in a plasma cutter are not cheap, and you got to keep the air clean. And again, it goes back to grounds. It's like everything goes back to grounds, really. It really does.
Yeah.
But a plasma, there's a lot of different plasmas out there. My personal opinion, Hypertherm wrote the book on plasma cutters. They hold 200 or 300 patents on plasma cutters. They are the best when it comes to plasma cutters.
Cool. So you say plasma, like what is it though? Is this just electrical charge? Like,
yeah, the electricity that they put into the nozzle, and when it separates, it creates plasma. So they're actually they're burning the air.
Gotcha.
It is. And then they force it through a little hole with the air, thus you can cut.
I'll be dang. So okay, so when one of the concerns, now this is a frank concern that I've never put effort into figuring out. So everybody in the chat can laugh at me, but all right. So whenever you are cutting a propane tank with a plasma cutter, because I've had people ask me, aren't you scared about the oxygen coming through there with the compressed air? So what is left over? What is the byproduct coming out of that with that torch? Is there compressed oxygen coming out that torch also that's unburnt?
I'm gonna say no. I could be wrong, but I'm gonna say no.
Okay, I don't think so either, because like to get that intense of a, like we're looking for some force, and then we're looking at that, like you said, the plasma coming out of there that's making the cut. I mean, I've never had any issues, so I never even worry about it. We cut tanks with them for years.
I don't. I mean, no. If it's there, it's going to get burned up. I mean, that plasma is hot. I don't know what the temperature is. No, I don't. No, I don't think so.
It's kind of like asking. Yeah, it's kind of like asking if there's unburned oxygen coming out of the oxy torch when you're done. You're like, no, it's all burnt up. Yeah, cool. Looks like we're getting some questions in here too. I want to make sure and grab them as we go here. Let's see. Yeah, here's a question here. He just bought a Lincoln 140 big pack. Dave did. And it's supposedly good for 5/16, but you're saying that's going to be at the top end of the duty cycle. It's going to be stretching its legs probably. He's wanting to know if it'll work for smoker building. So
it would depend on the material. How thick material.
Yeah, I would say like if as long as you're not like welding it all the time at that full, like you said, at that full end of it. If you're doing 10-foot run with that machine, you may want to stop and give it a rest. Maybe even bevel and make some multiple passes is what I would say. But,
so Frank, I explained to people what a duty cycle is. A duty cycle is on a 10-minute cycle. So if you run that machine, say that machine is a 40% duty cycle machine, you can run that machine wide open for 4 minutes, and then you must let it rest. If not, it's going to overheat. So that's basically what a duty cycle is. It's based on a 10-minute usage at wide open. But nowadays, I've noticed that they have broke it down. They'll do 100% or do like a 60%. So you really got to watch your duty cycle, especially on the newer machines, because An old machine, you get an old machine hot, you just quit welding, it'll cool down and be all right. These newer machines, if you get them hot, you could damage some stuff and they'll never work again, never work right again.
So is it just system wide that it damages, or is there one main component that fails?
Whatever is doing rectification. So we get heat when we rectify AC to DC. That's where the heat comes in. That's where we get a heat problem there, is when we rectify from AC to DC.
Yeah, and that's in all that magical coil pack looking stuff in there.
Well, that's why the heat sinks are made out of aluminum, so they dissipate the heat. So
Gotcha.
that's where your heat's going to happen. All your thermostats are either going to be inside your transformer, or they're going to be on the rectifier plate itself, because that's what's going to get hot when you're rectifying AC to DC.
Gotcha. That's great. Here's another question real quick here. Richard, I have a titanium unlimited 200. Can you recommend a better and longer gun that will fit? Do you know that's I don't know. I think that's the Harbor Freight one. I'm not really too familiar with the mechanicals.
I would have to know what ends on the gun. If I seen a picture of what end was on the gun, there's only, I don't know, 4 or 5 different ends out there. Typically, those machines, they either use like the old Tweco style or like the old Hobart style before Miller bought them out, which was a thin power pin. But I'd have to see the end of the gun to tell you that. But I'm sure there is a longer gun. Usually guns on these smaller machines are anywhere from 10 to 12 foot. Excuse me. You can get up to a 25 foot for some machines.
Wow, that's cool. Yeah, so there's a couple of companies I think that make the aftermarket ones. What is it, like Profax, and what's the other one?
Yeah, it's depending on the power pin, though. That's what we really got to look at, is the power pin and how the trigger connection hooks up. That's 2 things. That's only 2 things we got to worry about: the power pin and how the trigger wire hooks up. And you can always cut and splice a trigger wire if you had to.
I was just about to ask that.
Yeah, you're just making a contact or closure. It doesn't matter.
Yeah, that's cool. Yeah, I don't know much about those Vulcan machines. Have you ever worked on any of those?
I can't say I've ever seen one. No, sir.
Yeah, they're kind of a well, I don't want to say a throwaway machine, but it is a Harbor Freight machine. And I've never run one, but Bob has a couple down there that somebody dropped off one time or another, and he's run them through the races. And he says for somebody that just has a garage welder, that they do okay, if you're not using it every day and stuff.
Sure. Yeah, I would think that'd be fine for everyday repairs around the house. Yes.
Yeah. So a little bit about CO2 here. My brother Ron, he wants to know if he can run CO2 when he's mobile. And I don't know what, Aaron, if you could develop that question just a little bit to let me know what process you're doing. Bob says, give me your recipe. We'll let him pop back in. Let me know what you're doing.
So CO2 runs hotter than 7525. A lot of people like to run CO2 because it's cheaper, but you will penetrate deeper in the weld with CO2. If you run CO2 hard, it will freeze up. So they actually make heaters that go on your regulator to keep that from happening. They plug it into 115 and they heat that CO2 up a little bit. The advantage of CO2 is really just cost of shielding gas.
Yeah. Well, and I think it's liquid in the bottle too, isn't it? And so you get a lot more out of it. That's freezing up because it's changing state, I think, in the regulator. You ran out of vapor. At least that's what's that?
You pull vapor. Well, you pull vapor off the head of the tank. Yes. So if once you get past that vapor, you're gonna start pulling gas. You are correct.
Yeah. Okay. Yeah. So he was asking, Aaron just chimed back in again. He said, when plasma cutting.
CO2 for plasma?
Don't
recommend it.
Yeah. I've never heard of it. So I was just curious.
No. I mean, you can run compressed oxygen, compressed air, but not CO2. No, sir. I don't believe you can run CO2 with a plasma cutter.
Yeah. So you'd have to get like a
moisture problem. Be my biggest concern.
Yeah, yeah, for sure. Yeah, so whenever I was doing it, I either just had a generator and a small compressor that would run enough air, or I would just have a gas air compressor. But there again, if it's really humid outside, you can get into some moisture issues and stuff. Like you said, you got to have good clean air. Yeah.
I've
So,
had plasma cutters come in for repair, and I pull the trigger and water squirts out the head of the torch.
oh my God.
It's not a good sign. That's something's wrong. So yeah, I mean, most plasma cutters have a filter on the back of them, but you should also have a oil and air separator before it gets to the machine.
Yeah, oil is another concern for sure.
And you'll
We
get that out
always,
of your,
what's that?
and you'll get that out of your compressor. You'll get oil
Yeah.
out of your compressor. So that, and if you get that in the consumables of a plasma cutter, you're just wasting money on consumables.
Hmm. Yeah, I know that, watching Tom up there run that plasma table he's got, I mean, it's always him versus the air. We put crazy serpentine water separators in and, helical ones and, desiccant dryers and just all kinds of silliness just to try to get a little bit more consumable life. And
Right.
it's everything you can do to protect it. It
Yeah.
looks like to me, tell me what you think, but it looks like to me like when moisture does come through, the first thing it does is it ovals out that tip on the gun.
Correct. And then, if you look at your electrode, there's a little silver spot in the middle of the electrode. That's called hathium. And when that starts to deteriorate, your arc's going to deteriorate. But your nozzle, when you start to see your nozzle widen out, that's what your cut's going to look like. So you're not going to get that nice fine cut you're looking for.
Yeah, yeah. On mechanized torches, it's a pain because you're trying to get that real high quality cut.
Yeah, I mean, and you got to keep in mind when you're plasma cutting, the faster you can cut, the cleaner the cut's going to be. So if you take your time and mess around, you're going to have all that draws on the back of your cut, and you got to clean all that up. But if you can get a nice, straight, fast cut, you'll get less of that draws, and that's really key in a plasma cut.
Oh yeah, for sure. See, make sure I got all these questions here. Yeah. So do you guys have a lot of equipment in stock up there? If guys are like looking for a certain machine?
Yes, sir. Like I said, we have one store that is dedicated. It's just a warehouse. That's all it is. We don't do no service there. The only thing we do is fill online orders out of that location.
That's something that drives me crazy is, you get to a lot of these smaller local welding supplies, and it's like you go in there and every single thing you're looking for, they almost got what you need, but they don't have it. Inventory is such a difficult thing these days.
Really
I was looking at the at Baker's gas page today, and I saw, piles of welders. I mean, some of them pictures, you guys got a big operation, looks like.
We roll. We if you need it, we got it.
That's super cool. Yeah. So here's another question here. Kevin's wanting to know about nitrogen when plasma cutting stainless. He's heard something about that, looks like. Allegedly, it cuts cleaner.
It does. It will cut stainless cleaner, yes, sir. But it doesn't work as well for mild steel.
Not for mild steel. So pretty much it's is it the gas that goes through the nozzle that actually makes the plasma, or is it just the separation of those pieces?
The gas runs through a swirl ring in your torch. So what that does is it swirls it. It gets that air or whatever you're using for a shielding gas swirling. And then when you pull the trigger, you get that swirl. And then when you pull the trigger, and that electrode and that nozzle separates, that's what creates the plasma. It ignites that gas that the swirl ring has swirled. Gotcha. So that's why air pressure on plasma cutters is critical. When it says set it at 80 psi, you should set it at 80 psi. If it's too less, sometimes it won't fire. If it's too much, you won't get a good cut. So it's very critical that your air pressure is set properly.
Oh wow, that's cool. Good to know.
And if most plasma cutters have a set option, So turn the knob to set, the air will flow, and then that's why you want to set your regulator. Don't set
Yeah.
it when it's just a setting there doing it like you would for your MIG welder, but you want it flowing when you set it.
Yeah, yeah, that's good to know. Yeah, I know that on the older 45s, the Hypertherm 45s, when not the new version that's got the automatic setting on it, but that's what I always did. I turned it to that set position, and it would flow continuously on air. Adjust
Right.
your regulator on the back of the machine until you get it where you need it, and then you're
Right.
dialed in.
Correct.
Yeah, that's cool.
Hypertherm's got a little green thing on there, and you put the needle between the green thing, and you're good to go.
Yeah, I always love it when everything's either red or green because I'm colorblind and I freaking can't see any of it. So I just got to guess it's in the middle. So anyway, so tell me a little bit more about like on the Miller machines or the Lincoln machines, as far as like when you're cleaning those out. You said to power wash it out. Let's say that we're scared. What's another alternative?
Just blow it out with air. Compress. Just take
Air.
air. Just blow it out. Yeah. I blow out every machine that comes in the shop, regardless. It guarantees will get blown out. But if it's, like I said, if it comes from a steel mill or, someplace like that, a power plant, it's going to the wash bay. It's getting washed out before I touch it.
Mm-hmm. Yeah. So whenever we're dealing with like guns and stuff, because I know there's probably a lot of guys in here that's had the liner blues in their MIG guns. I mean, I have changed out liners. It just doesn't make even any sense why these things fail. What causes those liners to fail other than kinking a gun, a hose?
So,
like it just seems to wear out.
Well, they don't really wear out. What happens is you get that dust and dirt from your shop is laying on top of your wire. So then you pull the trigger and you pull all that into your liner. To tell you the truth, Frank, 9 times out of 10, it's probably not even the liner. It's probably your inlet guide that's stuffed up with crap, because that's what's going to catch it first. A lot of guys run the little felt pads on there and they put some cleaner on it. But truthfully, it's usually not the liner. It's usually the inlet guide. I get machines in for repair, and the inlet guide is just jam-packed with crap, and you can't feed wire through that. So 9 times out of 10, it's really in your inlet guide that pulls to the liner. Unless that liner gets kinked somehow, it's really hard to really plug that liner up, because, most of us that run 035 wire, we run an 035 45 liner. I mean, it's not going to get jammed up with stuff. It's the inlet guide that gets jammed up the most.
So, and that inlet guide is whenever you flip up the wheel or whatever's on there, that's that brass cone looking fitting that's right there that the wire goes in.
Yes, sir. When you come off the spool, when you feed it through, that first guide that you feed it through, that's your inlet guide. Mm-hmm. Then you got your drive rolls, and you got an outlet guide. And a lot of times, it's drive roll alignment that's a problem also. So if you look down through there and that drive roll isn't lined up with your inlet and outlet guide, that wire is riding on top of that drive roll. It's not getting down in that groove and feeding properly.
Ah, gotcha. I never thought about that. So making sure that wheel is in the right spot is not offset.
Look at it, eyeball it, make sure it's lined up. There's a screw in the center of the drive motor, and behind the drive rolls are 2 spring washers. They're like wafer washers, and they're spring loaded kind of. So if you loosen that screw a little bit, that drive will come out a little bit, or it'll go in, vice versa. Got to make sure them drive rolls are lined up properly.
Yeah, yeah. And you're basically saying adjusting it if it has to be adjusted on the shaft?
Correct. Yes.
Yeah, where the shaft comes through the back of the machine, and so you got to take the sheet metal off to get to that.
No, sir. No, sir. When you're looking at your drive assembly, you're looking at your drive assembly, you got a bottom drive roll and you have a top drive roll. When you flip it up, you got the top drive roll. That bottom drive roll is mounted on the motor, feed motor. Okay. Inside there is either going to be an Allen head or a Phillips screw. And if you loosen that up, that drive roll will move out, or it'll move in just a little bit for that spring. So that's how you
got it.
Yeah. It's nothing. Yeah, I don't have to take sheet metal off or nothing. Just look at it. And if it's not lined up, you need to make that a little adjust. And it might just be a little bit, but if that wire isn't laying down in that driver properly, it won't feed properly.
Yes. So I've been welding since I was 17 years old, and I never, ever heard that. So that's awesome to know. I can't tell you like how many problems that probably was an issue contributing to the overall. Like we would have welders, man. I don't know. It just seemed like they just had a day that they worked and a day they didn't. And then you let them sit for a few days and then they come back, man. They just needed a rest. I don't know what it is.
I want to try that with one of my customers. Hey, it just needs to rest a little bit. It'll be all right.
So Tom and I think over at his shop over there, like we probably had 7 or 8 welders over there, you know, rolling around in different states of happiness. And that's pretty much what it was like. So we would put a liner in one, that thing would run like a striped 8, man. I mean, for a little bit, or you know, we changed the wire in another one, and it was just like, you know, Bob always talks about the guy that makes scratch marks on the machine where the knob needs to be, but then you didn't take into account the humidity and the outdoor temperature and the indoor temperature and the bubble point, the dew point. You didn't take all this into consideration, what the voltage was that day, you know. So how much of an impact, while we're talking about that, how much of an impact does incoming voltage have to do? Like if we're on, like in my building, it's 208 high leg, so it's 3-phase. So we've got 240 or 230, you know, at the machine. Well, we choose 230 on that one, but then let's say we move it next door to another building that's got a Y and it's 208. So or 212. How big of an impact does that voltage difference make on incoming voltage for a machine?
Standards 10%, give or take, is what industry standards is. I don't feel that it's a real big issue. As long as you're within that 10%, you'll be fine.
Cool. So whatever the machine calls for, if we're on the lower end of the machine and it's set at 208 incoming power, you know, 10% of that would be good.
Yes,
plus or minus. Yeah. And then likewise, if you got 240 coming in and but the machine's got a tap for 230, you know, you're probably all right.
Yeah. All right. Yeah, run it. Because especially in bigger cities, I used to work in Detroit back in the day. And some days I couldn't even test machines because the power was so bad. Because you get all the people in Detroit, you know, fire their air conditioners up for the hot summer weather, and my input power would be below 200. So I can't even fire a machine up. So, and if you get if you live in an area where you have a lot of factories around that are really sucking up a lot of power, you could see problems.
Yeah, I would imagine so.
Because they're sucking it all up.
So how much do you think the environment has to do with like humidity? Like if you're working in a sweaty old freaking shop and, you know, it's 80 or 100% humidity outside, you know, or in the shop versus an air conditioned environment, how much of an effect do you think that has on the equipment?
On the equipment, I don't feel it has much to do with the equipment. The welder itself, the guy that's got the gun in his hand, has a lot of effect to him. He's too hot. He don't want to weld. The welder ain't welding right, boss. It ain't working. I don't feel that. I don't feel that the machine itself sees that.
Yeah. So it's a person problem.
It's a welder problem. Yes, sir.
Yeah, welder. Is it welder or welder?
Weldee or whatever you want to call it.
Weldee. That's funny. Let's talk a little bit about some TIG welding stuff. So did you work on a lot of the old Healy arcs, the LTECs and stuff like that when that first came out?
I've worked on some LTECs, mostly TIG machines, old Millers, old Lincolns, mostly. Some of the old Airco machines, stuff like that.
Yeah.
LTEC, I haven't really seen a lot of LTEC machines. I mean, I've seen a few through the years, but not a whole lot.
Yeah, we've got one or Tom does now. It's up at his shop. It's the LTEC that's at 250 HF. ACDC's got the Healy arc, you know, and Is HeliArc? I mean, basically, it's the same as just high frequency start on any other machine, isn't it? Or is
Well,
it different?
well, HeliArc is really just a form of it's old school TIG welding, as people call it HeliArc. It was just
Mm-hmm.
TIG. There's nothing different. They use
Mm-hmm.
high frequency. If you're welding mild steel or stainless, you're going to use a high frequency start. It's going to drop out once you establish an arc. If you're welding aluminum, it's going to be continuous. Uh,
Mm.
Now that will if you're running aluminum TIG, humidity will cause you a problem because of the high frequency.
Yeah. So what exactly is happening there on that to generate that HeliArc, that electric start like that? So the reason I'm thinking about it is that LTEC, you take the cover off and you're welding, and it's literally like 2 points with lightning between them that's just sitting there humming and hissing.
Yeah, yeah. So basically, a high frequency circuit is this. Typically, it's a 115 supply. So they take that and they supply a oh, we're drawing a blank now. They're supplying a transformer,
Mm-hmm.
and so they put 115 in, and they get real high voltage out. Don't ever put your meter on high freak to try to read it. Trust me, I know it'll be gone. It'll smoke.
Kablooey.
It'll smoke your meter. It'll be crazy. So they put 115 into it, and then they get a high voltage out, and they run it through a series of caps to smooth it out, and that's what you're seeing across your high freak points.
Wow. Okay. Cool. So yeah, don't check that with your meter.
No, sir. No, sir. Do not do that.
What happened when you did it?
You'll take a $500 fluke meter, and it'll be done. It's throw it in the trash
Yeah.
behind. So it's probably I think it's about 60,000 volts.
Mm-hmm.
Real high
Yeah,
voltage.
it's a bunch.
Real high voltage, low amperage, but the voltage
Yeah.
is very high. But
Yeah,
they take
that's
so
cool.
they take that and they run through some caps to smooth it out, and that's what you use for high frequency. And they do that. The reason they use high frequency on stainless or mild steel is to establish the arc without contaminating your tungsten, so you don't have to touch the work, so you don't contaminate it.
Yep.
In AC welding, they use it for the same purpose, but they also use the AC to clean the material, to draw the impurities out of aluminum. Sometimes you get aluminum that's junk and it has a lot of crap in it, so you really got to pull it out.
Yeah, I've only welded aluminum a couple of times, and man, I tell you what, that's a lot of power going on right there at one spot.
Well, the aluminum sucks up so much heat, so you really
Yeah.
got to sock it with heat to get it up to that melting point. And once you start welding, once you start TIG welding
Mm-hmm.
aluminum, when you start to see the surface mirror, when you see it mirror, it's ready. But if it ain't mirror,
Cool.
it's ready to go. Some of the
Yeah.
best TIG welders I've seen are women.
Yeah,
Women,
I've heard that.
they just can TIG weld well. I mean, they can. They really can.
That's cool.
TIG welding, especially aluminum, to me is an art. It really is. It's tough.
Yeah. Yeah, I did okay. I only did it a couple of times. It was just practice. I wasn't making anything. But
Right.
man, you got to really put a lot of care into what your surface prep, your material prep. You got to have a clean environment. It's a
Yeah.
lot going on.
Aluminum is finicky. Yes, sir.
Yeah. So as far as like lift start TIG, how does that work? As far as like how was that arc established? I mean, we're going to touch the tungsten to the material, lift it up, and that's where you're talking about the contamination of the tungsten because it might pull a little material up onto the tungsten, I guess. But like,
Correct.
is it just like that gap that when we lift that up, that's letting that arc start?
So when you go to try to start an arc, you have your gas flow. So your flow is shielded from the atmosphere, and then when we start it, we short it out and we lift it. It starts at it stays in that cone of the shielded gas,
Mm-hmm.
basically.
Yeah, that's cool. So getting back in, guys, if you got any questions, feel free to drop them down there in the chat, even if it's about your own welder and issues you're having. But I really wanted to talk about grounding and stuff like that. As far as like different methods of grounding, is there one method that you prefer over others for guys to use? Like, say we're working at a bench, like a clamp, or should we use one of those magnets, or what do you think is the best for that?
Personally, I feel the best is an actual ground clamp. And what a lot of people do is they'll be welding on something and their ground clamp will be 5 foot down from the project. So now the current goes from the ground clamp all the way up to your electrode. You should always keep your ground close as you can to where you're welding. Your ground should be clean. It should be tight. The magnets, they work well, but I think a good old-fashioned ground clamp is the best.
Mm-hmm. So a lot of the times,
I think Jackson makes the best ground clamp. I think personally.
That's good. Is that big brass one?
Yes.
Brass looking one? That big, hard to squeeze one. Yeah, that's the one I like.
Because it happens through time. When you have a poor ground, the ground gets hot, the spring gets hot, and once that spring gets hot, it loses the tension. So then, you have a bad ground.
Gotcha. You're not squeezing as hard that way. So as far as like keeping your clamp closer to wherever you're working, like you're saying, like just freaking unhook it and move it up within a couple feet of wherever you're at every time.
Yes. I'd move it a couple inches because you're right there. So if your ground clamp's 5 foot down, your currents travel all the way down through that work to get to your electrode. Where if you move that clamp closer, there it is.
Yeah, because it's completion of the circuit for the machine that matters, right?
Correct.
Yeah, that's what's going to get you the best performance. So because I know that like sometimes we would just set a flat piece of steel on the floor, we would just have a good tab kind of turned up, and we clamp it there, and then we'd weld the whole cooker that way, and it would get moody.
It's not wrong, but if you want to do it properly, you should keep your clamp close.
Mm-hmm. Yeah, that's good to know. So as far as like connectors, because I know there's these kind that you can hit and tighten down on your wire when you're connecting different kinds of fittings together. Like I'm thinking about the eyelet where you connect to the machine.
Yes, sir.
Like what kind of connectors and stuff should we be looking at? Because if you put a bolt in, a lot of times it pushes the frayed out wires away, it seems. Is there any tips on like connecting?
So you're talking like on the end of your welding lead, your connector goes into the machine?
In the machine, yeah.
Mm-hmm. Like the LC40s. LC40 is probably the most common. Well, what a lot of people do when they replace those ends, like if you buy a Jackson LC40, it comes with a couple of things. It comes with an Allen head and it comes with a strip of copper. Well, that strip of copper is not supposed to go in your scrap bin. You're supposed to wrap that around the end of the cable, stick that in there, and then when you put that set screw in, instead of all them wires fraying apart, they're wrapped up. They're going to get a better connection.
That's good to know. Yeah. I know that those twisty ones, the ones that you like put in the machine and twist, I had a couple of those that the tab wore down, and I had to replace those. And there was one that I got a hold of. I don't remember where I got it, if it was, but anyway, it's a mechanical fitting that like tightens down over you shove the wire in there, and then there's like a collet almost that tightens down around the wire. I don't know have you ever had to replace any of those?
I don't believe I've ever seen that kind. You talk about on your ground or welding lead?
Yeah, so like on an ESOB, when you can move fittings around, and it's got that little tab that like it's a tang that sticks off the side of the brass. They stick it in.
They call that it's called a DINS connector. Yeah, they call those a DINS connector. But I don't ever think I've ever seen one that was mechanical. I've always seen them that were just with a set screw and you just tighten them down.
Oh, maybe that is what it was. I'm starting to think back. I think it was a set screw. It was like Profax, I think, maybe made the connector.
Yeah, like a 5/32 Allen head in it that you would tighten up and tighten down. slide your boot back over and you put a little set screw in to hold the boot in place.
Oh, okay. Yeah. You know what? Now that you say it, I think that is what it was. I don't know what I was thinking with the twist part, but yeah. So as far as like gun tips and stuff like that, like we're talking about the consumables, we wind up chasing contact tips, things like that. You see some of these sprays that are coming out to keep your gun clean. Then you got nozzle dip and BB butter. Like, what are your tips on some of that kind of stuff?
Get you a pair of Welpers and clean your nozzle out and go on with the day. That's my
Yeah.
personal opinion. Because you spray that stuff and you dip it and it's all over everything. To me, it's just a mess. It's just anti-splatter, so the splatter doesn't stick to the nozzle. Where if you would take 2 seconds and just pull the nozzle off with a pair of Welpers and just clean it out and put it back on, you'd be all right. You save yourself a couple of dollars in nozzle dip. I'm not a person, but I'm not a welder. I don't weld every day, so that's just my personal opinion.
Yeah. So what I've always found is that I get the Welpers, and I use them for cutting my wire off, but I'm not even thinking about the nozzle. So I just throw them back on the bench and I start welding again. Before too long, I'm looking down in the end of the nozzle when I start getting a little bit of porosity, and it's shot, man. So
if you look at your Welpers, it's actually it's got a lot of tools on it. So a Welper, you take your Welpers, like I said, and you take the pointy end, put it down on a nozzle and twist it. It'll clean all that slag out of it for you. It's also got a little place to loosen your tips up. Most people never tighten their tips up. They take it, they put it on with their finger, and they tighten it up. It's wrong. Your arc transfer takes place at the tip. You need to be tight. You need to buy the proper tips for your gun. A lot of people go to these places, they buy tips, and it's not even the tip for their gun. They got a Miller machine, a Tweco gun, so they go to the store and they say, what kind of machine you got? Well, I got a Miller. So they give them Miller tips. Well, they take them home and they jam them down a Tweco gun. It's not the same thread. It ain't going to work. It'll work. It will, but it ain't right. Also, make tips wear out. I can't tell you how many times you got a machine for repair that's running 035 and you could run 064 wire through the tip. They just continue to use that same tip, but that's where your arc transfer takes place, is at that tip. It's not as critical in MIG welding mild steel, but if you start doing a lot of aluminum MIG welding, especially like a spool gun, and you get a tip wore out, you'll pull your hair out trying to figure out what's wrong, and that tip is the problem.
So what is the problem? What wears out? Is it just ovaling out the hole?
Correct. I mean, when you put a new tip on there, you run 035 wire. If you look at it, it's tight. I mean, it's a tight fit. Once it wallers out, you're not getting that good arc transfer that you used to get before.
Yeah, and so is that the arc transfer coming through the liner and all of that stuff up into the contact tip?
The liner, the only liner only feeds wire. It's all the liner does. Your MIG gun has copper in it. Copper cable that's attached to the power pin that goes into your drive rolls. The current actually flows through that cable, not the liner. So all the liner does is feed wire and allow the shielding gas to pass through. So the actual arc the actual current is going through the copper in the gun.
Gotcha. Yeah. And then one thing I do want to point out is on the Spray Master guns, I think for the ESOB machines, it's got that tip that drops in, and then you got the nozzle that tightens down. Don't stick the Welpers in too far. That's a bad deal, because it'll like wear that thing out, and then the tip doesn't stay in.
The diffuser, yeah, we go to the diffuser.
Yeah.
So at the end of your MIG gun, excuse me, you have a diffuser, an insulator, a nozzle, and tip. Those are the components at the end of a MIG gun. The diffuser usually never goes bad until you burn it up, or it gets jammed up with slag, which that happens a lot. Then you get poor gas coverage.
Yeah. Yeah. So have you ever so what's happening with that insulator is it's keeping the nozzle or whatever what is that? Is it called the nozzle? Okay. I've always called it the nozzle. I just want to make sure I was right. So the nozzle winds up, like if you ever get in a situation your nozzle sticks to the material, that means your insulator is bad, right?
Correct. You're getting welded into the nozzle, which you shouldn't. You should be able to lay the nozzle on your work, and it should never arc. That's really the nozzle. Really is just there to force the gas into your weld.
Yeah, you know, it's one of those things that most people never even think about. So I hate that I'm sorry if I'm asking too simple of questions, but there's a lot of newbies out there that just don't know, you know.
I see it all the time.
Yeah, I seen a guy throw a gun one time just because that nozzle kept sticking, you know, and I'm like, dude, you got to change the consumables, you know.
Right. Exactly. Yeah.
And don't throw the gun down every time you're done. Just don't drop it. Like put it in a place where it won't fall off. You know, like clean all your drinks and shit off the firebox, and like let's find something to actually anchor your gun so you can set it down.
Right. That's why a lot of them have hooks on them so you can hang them up.
Yep, that's cool. I tell you what, Roy, I've had a blast talking to you, man. I hope that everybody found this helpful. I look forward to having you on again. I really want to have you and Andrew come down to the shop and just hang out with us at one of these welding classes. I think that would be a ball. Have a big event. Yeah.
Yes.
So tell everybody how they can get a hold of you. Do they let you guys ship do they let us ship welders to you to work on and stuff if we have issues? Like, how does it work?
Sure. If you want to drop something in the mail or ship it to me, I've got machines from Florida. I've got machines from all over the country. You know, usually it's my like ESOP rep or my Miller rep. They're having problems somewhere, and they say, "Oh, I know a guy can fix it." They'll send it to me, and we'll look at it and we'll fix it. But yeah, you can drop ship anything to bakersgas.com. You can find us on the line, and I fix. I'm a certified Miller, Lincoln, ESOP, Hypertherm. All your major brands. I do all warranty work for all those brands. And I work on, like I say, I work on any other brand too. It doesn't really matter to me. But
that's great. Yeah. So even old machines, right? If we got an old yellow, old brown.
I prefer old machines, to tell you the truth. I like to work on older machines better than I do new machines. Yeah.
Yeah. What about like Lindy? Have you ever worked on a Lindy?
Yes, sir. Yes, sir. Mm-hmm.
Yeah.
Mm-hmm.
I know a guy that's. Go ahead. I'm sorry. I keep cutting you off.
Back in the day, it used to be your Union Carbide.
Oh.
Lindy, Union Carbide. That's way back. But yeah, there used to be a green and yellow machine. Mm-hmm. But yeah, I think I've worked on machines from the 50s. Yeah.
That's cool.
Yeah. So, but I prefer the machines, like the old SA200s were always fun to work on. I've done some work on like stud welders, like 2,000 amp stud welders that have like a big GMC diesel in them. I've worked on pretty much everything out there one time or another.
That's cool. That's cool. Well, right on, brother. I super appreciate you being on tonight on such short notice. I know I just hollered at you last night. I've been traveling a lot for the barbecue stuff, but anyway, guys, if you need anything at all, check out bakersgas.com. They're a big old outfit, and they got a Roy, and that's important. So anyway, appreciate you, brother. Guys, till next time, keep your smoke thin blue, and we'll see you next Friday night.
Take care.
Have a great one.
Bye.
Yeah.